Hello, I am Anvita Birje. Today we are going to see the topic that is Introduction to Basic Instruments. In this, we'll see components of generalized measurement system, concept of accuracy, precision, linearity, sensitivity, resolution, hysteresis, and calibration. First, we'll start with measurement and measurand. Measurement is the act or the result of a quantitative comparison between a predetermined standard and unknown magnitude. In short, it is the process of measurement. In this, we can measure any quantity. Measurand. Measurand is the physical quantity or the characteristics condition which the object of measurement is an instrumentation system is termed as measurand. So measurand, in short, we can say it is the physical quantity to be measured, like length is the measurand, and the process of measuring length is known as measurement. Measurand may be two types, fundamental quantity and derived quantity. Fundamental quantity is such that length, mass and time. So it can be measured directly. So we have the unit of length like meter, weight that is kilogram, second. These are the units of fundamental quantity. Derived quantity. Derived quantity means it is the product or ratio of fundamental quantity. For example, speed, velocity, acceleration, pressure. So for example, if you see the unit, it is meters per second. So meter and second. So it is the ratio of meter and second that is derived from the fundamental quantity. Now we'll see the components of generalized measurement system. It is basically four blocks, that is transducer, then intermediate stage, and the final stage consists of pointer, digital indicator or controller, and the last block that is power supply. The detector is the first block which is having transducer stage. The transducer which converts the physical quantity into electrical signal. That electrical signal means if you are measuring temperature, then we cannot measure temperature directly. For that we need sensors and transducer. So sensor will sense the temperature and it will convert it into electrical signal. That output of transducer is given to the next stage, that is intermediate modified stage, which is nothing but signal conditioner or preamplifier, which is used to convert the transducer output into the electrical quantity suitable for control, recording and display. So in this, the output of transducer is very low, so that can be amplified with this intermediate stage. So our last stage is the display. In this, the display or readout devices which display the required information, and that can be displayed by using pointer or any digital indicator, so directly numbers can be considered, or sometime the controller also used to take the appropriate control action. And the fourth block is power supply, which is electrical power supply, which provides the required excitation to the transducer and other electronic circuits. Now we'll see basic characteristics of measurement system. A knowledge of the basic or performance characteristics of an instrument is essential for selecting the most suitable instrument for specific measuring job. It can be divided into two categories, that is static characteristics and dynamic characteristics. The static characteristics is constant or varying slowly with the time, but the dynamic characteristics are rapidly varying quantities. Now we'll see one by one. These are the static characteristics of instrument. First we'll see accuracy. It is the degree of closeness with which an instrument reading approaches the true value of the quantity to be measured. Means it is the exactness of instrument compared to the expected value. Means it is comparing the expected value and the standard value, or the desired value and the observed value. Accuracy is the ability of an instrument to show exact reading. Next characteristics is precision. It is a measure of consistency or repeatability of the instrument of measurement. That is, successive reading do not differ. It is the capability of instrument to show the same reading when used each time. Means if you are measuring voltage on the multimeter and you are taking the reading 10 times, so 10 times for the same voltage you should get the same reading. That is known as successive reading, which is same at all the time. An equipment which is precise is not necessarily accurate. For that, we'll take example or the difference between the precision and accuracy. If you see the example, the X is the value, reading value, or you can say result. This expected result, that is true value, is at circle. So if you see the first figure, it is known as highly accurate and highly precise, because all the readings having the same values which is in the center. So it is accurate and precise. If you see the second figure, in this values are precise because all the 6 values are at the nearest value, but it is away from the circle, therefore it is not accurate. The last figure is low accuracy and low precision because it is away from the circle and all the values are differ from each other, so it is low precise. Next term is linearity. It is an ability of instrument to reproduce its input linearly. It is normally desirable that the output reading of the instrument is linearly proportional to the quantity being made. So when you consider the VI characteristics, in that the V and I are linearly proportional. Sensitivity. It is the ratio of change in the output of an instrument to the change in the input. The smallest change in the measured value to which the instrument responds. So whatever the change in the output, that should be reflected in the reading. The sensitivity is calculated by change in Q0, that is delta Q0 divided by delta Qi. Here the delta Q0 in infinite testimonial change in output, and delta Qi is infinite decimal change in the input, that is the smallest change. The sensitivity of the instrument should be high. Resolution. It is the smallest change in the measurement variable to which an instrument will respond. The smallest change of the input for which there will be change of output. Next term is hysteresis. When the input of an instrument increases, it gives some output reading. That is, it is following some curve, that is from variation from input to the output. But with decrease in the same input, it gives different reading as shows in figure. Then this effect of instrument is called hysteresis. So basically hysteresis is the difference between the two curves. This hysteresis is caused due to friction, mechanical flexure of internal part and electrical capacitance. Calibration. Calibration is the process of checking by the comparison with a standard the accuracy of measuring instrument of any type. So in this we have one standard instrument, and with that the other instrument it checked. It may also include adjustment of the instrument to bring it into alignment with the standard. If the standard value and the actual value is not matched, then the alignment is required. That process is known as calibration. The next is error. It is the difference between the observed value and the desired value. So whatever the expected and what is observed, that difference is known as error. The error is calculated, which is absolute error is the difference between true value minus measured value. The next we can calculate relative error. The relative error is defined as it is the ratio of absolute error upon true value. The absolute error is the difference between true value and measurand value. Then we can convert this value into percentage, that is by multiplying 100 with the relative error. Okay, we can see one example, like true value of the measurement is 122 millimeter and expected value is 120 millimeter. So in this, first we can calculate absolute error, that is the difference between the true value and expected value is 2 mm. Then relative error is absolute error divided by expected value. So relative error has no unit, and then when you multiply that relative error with the 100, we'll get the percentage error, that is 1.7%. Now we'll see dynamic characteristics of measurement system. In that we have speed of response, fidelity, lag and dynamic error. Speed of response. It is defined as the rapidity with which a measurement system responds to change in the measured quantity. Means whenever we are changing the signal, then the output should change. So time taken by the instrument to change if the effect, that is known as speed of response. Fidelity. It is the capability of the system for faithfully reproducing the changes in the input without any error. Lag. Lag is nothing, it is the delay or retardation in the response of measurement system to change in the measured quantity. So there are two types of lag, retardation type and time delay. In the retardation, the response of measurement system begins immediately after the change, but in the time delay, the measurement system begins after a dead time. Dynamic error. Dynamic error, it is the difference between the true value of the quantity changing with the time and the value indicated by the measurement system. That is, it is the difference between two value, expected and observed value, with no static error. So here we have finished all the parameters, that is dynamic and static characteristics. Thank you.